Hello, welcome to the Canidae to Gantner integration video. Canidae is a brand new cutting-edge technology in the world of vibration monitoring and control industry. This technology allows for the relocation of the computational unit inside of the actual sensor, empowering vibration transducer to collect, digitize, and reduce vibrational data to actionable outcomes. The computational results, also known as condition indicators, or simply CIs, are reported over CAN bus to other sensors, data repositories, or alarm triggers to be acted upon.
Here we have a typical Gantner Q.station 101 DT unit. Devices like this are typically found in test cells, production lines, or any other type of industrial automated environment. The architecture of the Gantner Q series requires a Q.station controller, along with modules for data acquisition, data input-output, and additional communications. Having said that, in order to introduce a vibration monitoring and control system using a typical IEPE, variable capacitance, or piezo-resistive accelerometer, it would require a user to purchase additional modules and invest a significant effort developing data processing algorithms. However, like many other industrial process control devices, Q.station has two independent CAN modules. This makes it possible to switch the measurement chain architecture to utilize CAN-MD technology. Now, up to 62 vibration monitoring sensors can be connected to the Gantner controller, performing sophisticated vibration analysis and reporting actionable results to be displayed and acted upon. The process of integration starts with condition indicator definition. This is a typical process for any machinery vibration monitoring setup. In order to define useful and robust condition indicators, it is necessary to know the machine, rotating frequency, operating range, as well as major modes of the equipment. The mode frequencies can help in setting up reliable condition indicators, as machinery faults tend to excite the modal frequencies. As the faults keep developing, the excitation amplitude increases. Thus, diligent trending of the properly selected condition indicators can be used to indicate a developing issue. CAN-MD vibration sensors are standalone devices which come with a very detailed interface control document. The ICD defines all the message formats used to communicate with the sensor. Having the ICD in hand, it's a straightforward process to program and control the units for the CAN-MD sensors. However, in order to streamline and simplify the integration process, it's recommended to use Dytran Sage software package and hardware. The equipment being used here is a CAN-MD developer kit. Please visit us at dytran.com for the details and options of our developer kits.
The connection to the logger via Wi-Fi is very similar to any other Wi-Fi device. CAN-MD logger is identified as CAN-MD_serial number, so it is easy to find. The new setup is created using the tablet interface.
The modal frequencies are identified using a RAP test, where the machine is tapped with an impulse hammer to excite a broad range of frequencies and determine which of these are amplified by resonances in the structure.
A typical setup for the RAP test consists of time domain and frequency domain outputs, to make it easier for the user to visually identify the frequency bands of interest. The review of the data shows very distinct peak at around 3500 Hz for node 2 and well-pronounced energy area between 3 kHz and 4.5 kHz for node 3. Node 3 also has some broadband area between 1 kHz and 2 kHz. By running the setup at its intended operating speeds, the user can further observe the typical spectrum of the machine, which can also help in setting up useful condition indicators. After the appropriate peaks and frequency bands are identified, the corresponding condition indicators can be set up to be calculated on the sensor proper. Once the setups are synchronized, the CI trend can be viewed on the tablet screen. At this point, the user can disconnect the tablet and the logger from the network and connect it to the Gantner unit. The following spreadsheet shows the list of CIs the sensors are programmed with, along with the CAN frame format derived for these CIs using the ICD. The definition of the CAN IDs for each condition is derived from the ICD of the accelerometer. The name of each condition indicator is associated with the appropriate CAN ID for ease of integration. Test Commander software allows the creation of variables based on the payload data within a CAN message. Two variables must be created, one for the condition indicator value and another for the conversion factor. The math operation can be performed between those two variables to express the actual value of the condition indicator. Then, this value can be used to turn on and off the logic outputs of the Gantner module to signal the light or stop the machine. The user needs to use test.con to update the user interface or LCD display on the Gantner instrument. Download the variables and parameters we set up in Test Commander. Next, set up the graphs we want to show. In this example, we used HMI trend riders for our time domain graphs of data.
The CanMD system will constantly monitor the vibration profile of your machine and report the findings to the Gantner unit. The Gantner unit stores the data for future analysis and can make the conclusion of the machine's condition. It will signal the operator with color-coded alarm levels and will decide if the machine needs to be stopped to prevent catastrophic failure. The operator will be able to review the CI trend that shows the incremental increase of the condition indicator values to understand what caused the system to shut down. He will also be able to observe the spectral domain signal as well as the time domain signal from which the critical condition indicators were calculated. In our case, the fault was deemed to be a bearing failure. The setup was disassembled to examine the bearing condition. The results were confirmed by visual examination of the bearing. We hope you found this CanMD integration video informative. If you'd like to learn more about CanMD, please visit our website at Dytran.com or contact our technical support team via email at canmd@dytran.com. Remember to subscribe to the Dytran Instruments YouTube channel for more informative videos and innovative products from Dytran Instruments.